Welcome students. We are given this f of x is equal to integral x squared to x squared positive 1 e raised to the power of negative t squared times dt. Then we have to find the interval in which f of x is increasing. So by Leibniz rule, we can actually extract f dash of x as e raised to the power of negative of x squared positive 1 times d over dx of x squared positive 1 negative e raised to the power of x squared times d over dx of x squared. Okay, so when we substitute the upper limit, there is a square term involved here, so we need to place that square there. And similarly, when we place the lower limit, there is a square term involved there, so we'll have to place that. So having got this, let us simplify this. So this is x squared positive 1 whole squared. I differentiate this, I get 2x, and then e raised to the power of negative of x squared raised to the power of 2. I differentiate this, I get 2x. So what we can now do is we can take this 2x out and then rewrite it as e raised to the power of negative of x squared positive 1 whole squared negative e raised to the power of negative x squared whole squared. Now this can be further rewritten as 2x times e raised to the power of negative of, now let us expand this. This is x to the power of 4 positive 2 times x squared positive 1, and I expand this, I get e raised to the power of negative x to the power of 4. This is what we get. Now if I were to distribute say for example okay, so if I can take this term out, this is going to be e raised to the power of negative of x to the power of 4 positive 2x squared positive 1. So I'm going to take that out, so I'll get a 1 here. But over here, I have only x to the power of 4 with the negative sign. So that one can be neutralized here. But there is a extra negative 2x squared. So I need to have a positive x squared and a negative 1. So positive 1 has to be placed. So this is what we get. Okay, I hope you're following. Okay, the requirement. So what is the requirement? We need to find where f of x is increasing. So clearly we see that this quantity, okay, for every x, e raised to the power of 2x squared positive 1 is going to be always this is going to be greater than 1. That is a very important fact. Okay, so subsequently I'm going to place the condition here, the other result. When this is always greater than 1, what happens to this quantity? Okay, also for every x, e raised to the power of negative of x to the power of 4 positive 2x squared positive 1, this is always going to be greater than 0. Okay, now because this is always greater than 1, this means 1 negative e raised to the power of 2x squared positive 1 is, this is always going to be lesser than 0. Imagine the least value that this takes is say 1.00, 1 minus 1.00, right? Still is going to be less than 0, but in this case it is not going to take 1.00 because the value of e, even for the lowest value, the value of e is lying between 2 and 3, right? So in any case, this is going to be going down. So apparently this will have an issue because for x less than 0, 2x is always going to be less than 0. But our requirement is f of x should be increasing. So the only way it can increase So yeah, let me state down there. The only way f of x can be increasing if and only if x is element of negative infinity and 0. So the right choice would be C.